morning and the late afternoon than at night. Consumers don't notice it because it's just part of the background. It's unconscious but ubiquitous throughout the road system in Singapore. And then we have the node. This is unconscious and unique. Action in a specific circumstance. One of the capabilities that was developed in Japanese cars, and is one of these examples of something that's only available in a local case, is automated parking. In Japan, parking spaces are very small. People have difficulty in parallel parking. So, here's a great opportunity to take over and use technology to process the signals from the environment and park the car for you. So if you have a Toyota Prius or a Lexus, you can push the button, take your hands off the wheel, and it will park the car automatically for you. And even remember several parking spots for you, right? You don't have to consciously interact with the environment. These are all sorts of roles that technology can take on for us, because in the modern world we are overloaded with information, and technology should amplify some signals for us and attenuate others. The interesting thing about this is if you use that matrix, you can generate all sorts of possibilities of new businesses and services that can be created by recognising the characteristics that drive fundamentally information systems. I'd like to finish by looking at some critical global problems. We're talking about globalisation and information systems. We need to examine the role of information systems in solving the global problems that we face. The major problem that we face is high CO2 emissions. They have grown very rapidly in recent years. It may be that we're even past the turning point. The great consensus is this is a problem we have to solve. We have degradation of the oceans. The fish supply for many species is disappearing, and if you combine that with CO2 emissions, we have acidification of the oceans, which is destroying coral reefs and maybe the habitat of many species. We have declining freshwater supplies. In fact, they believe, many who forecast the future, that the wars of the future will be fought not over oil but over water. This will be the extremely scarce resource. And we have loss of biodiversity. Biodiversity is often a source of new drugs for solving current ailments. So I'm interested in developing a field of green information systems. How do we design and implement information systems that contribute to sustainable business processes? Because that's the problem we face. We cannot continue to use up the resources that we have because we're starting to run out of them. We have to create a new approach, and that is sustainability. For the last 50 years, information systems and the associated technologies have been the way in which we have improved the productivity with which we convert raw materials into products, and the way in which people work more efficiently. We have to take our knowledge of information systems and use those to solve and contribute to the solution of global warming. So there's a real challenge for those of us who work in information systems to start to develop green information systems. And here's the basic equation. What I believe is that we take energy plus information and we need less energy. And what is energy informatics? What is this new field going to be for us? We have to be able to develop and design systems to increase energy efficiency. This means three elements. First of all, how do we collect and analyse these vast data sets that will enable us to understand how we use energy currently? And in fact, I think there was an announcement today by Google that it's going to provide data to you in your home about how you use energy. It's that sort of level of dense data collection that we need to solve this problem. And then once we've got it, we can start to optimise energy distribution networks, such as the power grid in the US, which runs on 1960s technology. And if we upgrade it to current technology, we can get more electricity out of that system, and we will need less generation power. In fact, the problem they had in California several years ago could have been solved by better information systems. And we can start to optimise energy consuming systems. Let's have a look at some examples here of energy consuming systems. Fleet management. UPS has got a lot of publicity for its system of routing trucks for the delivery. In some cases, they only save 2 or 3 miles per day when the UPS truck goes around, but that adds up to 30 million miles in a year. The other smart thing that UPS has done is they continually monitor the performance of their trucks. Every truck is hooked up to a wireless system, and they are recording the state of the alternator, the viscosity of the oil, and a variety of things like that. Instead of replacing the oil or the alternator at every 30,000 miles, they can do a predictive diagnosis and say, well, with this truck we'll replace at 25,000 miles because from the information we get, we know it's about to fail, and this one we replace at 50,000 miles. That means much less waste in the environment. This is an important thing that comes from collecting information and data about what's happening in your environment. In the case of UPS, where are your trucks and what's the state of the engine in your truck? They can even detect if people are reversing, haven't put on their seatbelt and so forth, and they have retrained their UPS drivers that when they hop in the truck, the last thing they do is turn on the motor because that minimises some emissions. Southern Company is putting in wireless measurement of all their meters so that people don't have to drive trucks around the neighbourhood and hop out and read your meter. Now they read the meter once a month. What happens if I can read your meter wirelessly every minute? Think of the amount of data that I can get and then feed back to you so you can change your behaviour to use less energy. So turning off an air conditioning at some point when you don't really need it, or understanding how much energy is wasted when you leave your TV set on standby. In the area of building management, some organisations are getting really smart. Some universities are getting smart. They feed the timetable into their energy management system, their building management system, and they know how many students are going to be in every classroom throughout the day and adjust the heating and air conditioning to the size of the audience instead of running it at full blast when there are only a handful of students in there. Some companies are even getting smart and are measuring whether there's somebody in a cubicle or not and then adjusting the energy there. There are tremendous savings. Some of the figures suggest about 50% of the energy used in buildings can be saved by automation, can be saved by using information systems that measure what's happening very precisely and very densely, lots of measurement systems in the organisation, and then using that to manage the building. In fact, one of the projections is that the Chief Information Officer, the person who currently runs the information systems in the organisation, will become the Chief Energy Officer because it's fundamentally an information problem. If we have enough information, we can be much smarter about how we use energy. So what have I talked about this evening? What is global information systems? It's founded upon several things: ubiquitous networks, the internet, Wi-Fi, GSM, the cell phone system, Bluetooth, and a whole variety of networks that now exist. That's the foundation of these global information systems. And really, they've only started to emerge in the last decade or so with the internet, that we truly have global information systems. And this is the foundation of the next phase of globalization, because it's all about that combination of trade and technology. International standards, so that we get rid of the friction of the movement of information between organisations and countries and the friction of the movement of physical goods. And then English as the language of opportunity and the language of trade and the language of internationalisation and globalisation. And then we've learned something about professional and corporate cultures, which also span international barriers. And then we have these two local information systems that constrain what happens: language and culture. So if you're going to operate successfully in a global environment, you need to understand the fundamentals that are driving it and then be very good at adapting to local culture and getting past the problems of local languages. Our successes is that we built global information systems that give us goods and services for the developed economies. Those who live in the wealthy part of the world do well. Our unsolved problems are the bottom of the pyramid. We need to do more. We need to find ways in which we can do more with information systems for the many millions, billions of people who live on about $1.25 per day. And we need to solve this fundamental problem of sustainability. We need to meet the needs of the present without damaging the lifestyle of the future. This is probably the fundamental problem for this generation of professionals and scholars. The question that I leave you with is, how do we create global information systems that propel the world to sustainability? How do we create an environment that enables us to continue to live our present standard of living for decades more? Thank you very much for the opportunity to speak to you this evening about global information systems. It was an honour to accept the invitation. I hope that you have learnt from this evening and you've gained some insights, and that you will be better global citizens and greener global citizens. Thank you very much.
We have an opportunity for questions. If you want to ask questions of Dr. Watson, do we have some questions? Christine has a microphone.
Back on a college campus. The speaker stops talking to the students.
Yeah.
Right here. I imagine on some level, anywhere and everywhere you go, you're probably critiquing information systems. Just as you walk around, what do you think about UNF?
Well, I don't know enough about the information systems here. What do you have in building automation? Do you know how many students are in every room and adjust the heating or the cooling in summer? No. No?
They do shut lights off.
They shut lights off?
Yeah. You have to get up and turn it back on. It's physically done.
It's physically done?
No, in our building, it's automatically done. It's happened to me before at like midnight, all of a sudden the lights shut off. You got to open your door and reset them.
But it's probably one of the easiest things to do, actually, to walk in every organisation and criticise its information systems. The fundamental problem is we built some things 30 years ago, and then we have to keep building new things with new technology. What worked 30 years ago is incompatible with our modern systems, but how do we get the resources to bring all of those up to date and match with modern systems? Many banks are operating on systems that were written in something called COBOL, and they don't dare change them. So we've got this problem with all the new technology we want to use, but these legacy systems that are years old. And unless you're a brand new organisation, you face that problem.
Any other questions?
I can see.
Probably hear me. How do you see the conflict of interest between the trend, the green trend, and today's oil-based, fossil fuel-based economies, global economy?
The sorts of systems that I see, what I call green IS systems, are smart moves for the company. In the case of UPS, it means they use less oil, they're more profitable, they get better value out of their trucks and so forth. Southern Company is going to save a lot of money on the wireless metering, which is the economic argument, and then they discover with all of this data there are all sorts of other sorts of things they can do. Now, so there's a fundamental economic basis to many of this green thinking. Right? You can save a lot of money here by building automation. The other thing that's going to happen is there'll be regulations so that you level the playing field for everybody. And I think companies are getting ready for that with the new administration, that there will be some regulations, and that provided everybody has the same platform, we'll all move ahead into a greener environment. But at present, for some people to do it, they're at a disadvantage because it costs them. Right? So I think both of those things have to happen at the same time. But at present, there is enough opportunity to just go green on the basis if it's the smartest way to run the company.
Rick, on the note of culture, there was this paradigm that I was reading about when early information systems like the Windows and DOS world were developed. They were developed in this country, in the Western countries, and a lot of them got shifted to the developing countries like India. And along with that transferred a lot of culture. Now that innovation, a lot of companies in terms of cost saving have shifted a lot of that innovation to the developing countries. Is there going to be reverse culture? I mean, is that local culture from developing countries going to start influencing the information system that is developed and thus start influencing Western countries?
I think it's a good question. To some extent, you can already customize the system to the way you want it. I think the more fundamental thing is going to happen is that the way in which we determine what is required from the system and how we build the system will be determined by local cultures. So that, for example, if your development was done in the US, it's a different style of teamwork than if it's done in India, right, as you know. And so that will influence the way in which we create and build these sorts of systems. And I think you already see that, the way people interact. You see it in cross-cultural teams, how they adjust to each other's behaviours. So I think that's the interesting thing to study. The technology should be flexible to adjust to our local needs, right? Then it's good technology.
I think we're going to have to end it, Rick. Again, if you would join me in thanking Dr. Watson for coming.
Thanks, Jeff.
And we have a little token of appreciation
Thank
for
you very
your
much.
speech.
And it's mainly green as well.